Recording's rolling. It is Monday, September 8th. Welcome back from the weekend. So, last few weeks, I had you guys do some activity that I've been wanting to debrief, like that circles activity from a while back. So, we'll do a quick debrief on that. Also, the reaction time activity. Most of you guys got this. Like, remember, this was an extra credit opportunity. A few students looks like didn't, so we'll debrief that too. All right, why don't you guys just turn in your puzzles today? You guys remember for lessons 1-1, 1-2, and 1-3? Okay, so put those points in the grade book. Now, guys, over the weekend, I did figure out how to assign through Alex and ask my earlier classes, and it was like nearly universal. Everybody would prefer to do it that way.
Yeah.
Okay. Oh, yeah. See, you guys are saying the same thing.
Yep.
One of the advantages also doing it online is that you can know right away if you're getting it right or not because if you miss it, just gives you slightly different questions. All right. So this one paper that you guys are turning in today, but then after this, they'll just be on Alex. Right? Actually, the next lesson, which is this right here, which we're going to do today, I already have uploaded. So this is going to be due on Friday and have a quiz for you guys coming up on Friday. So here's how the rest of the week is going. So out of this book, we left off on lesson 1-3. I'm gonna skip 1-4 because I was looking at 1-4 and it doesn't really look like anything new or really worth their time. 1-5 is split into two parts. I don't know why. 1-5A is piecewise functions. Because we're going to spend pretty much the rest of the day looking at piecewise functions after I debrief these couple of things. Tomorrow we'll do just regular 1-5, which is absolute value, comes right after the book. Okay. And then Wednesday we'll do 1-6 transformations. My plan is to put in Alex and homework day on Thursday. Okay. Right. And then, of course, I can walk around and troubleshoot and answer any questions you guys have. The puzzles, which again I opened an assignment for 1-5A, 1-5, and 1-6 on out, so it's open right now. Opened that yesterday. Let's have these due on Friday, and then Friday I'll get you guys a quiz. So, is there any question about what we're doing this week? You guys good? Yeah.
You do a practice test like on Alex test.
What the Eastern Cultures?
Is that a practice test?
Like it's where you do like it's kind of like a test, but it's practice questions, so you know what the test is.
Yeah, I did open a bunch of practice questions for these. I mean, it's just practice puzzles. It's kind of the same thing as yeah, it's what's going to be on the quiz. Yes, sort of thing. It's not like timed or anything. Other than we brought it. Yeah, so pretty much that. I think just the assignment. It's okay. Right. So if everybody writes in their notebooks, they know there's an Alex assignment for 1-5A, 1-5, and 1-6. Right. Okay, got that. All right. So here we go back a few weeks in this class. Debrief the circles activity because there's something I want you guys to see from the circles activity, and yeah, I think some of you guys got what was going on, and some of you guys kind of missed it. So I had you guys measure or make measurements about these circles. One thing you guys measured was the radial size. Right? So I see big circles, I see medium circles, I see small circles. I had you guys take some string and wrap the string around and pull the string out and measure how long the string was. Guys, that represents the what of the circle? Circumference. Yeah. And okay, again, I see small, medium, and large circumference. Right. Then I had you guys count the number of tiles for each circle. Because the number of tiles represents the what of the circle? Area. Yeah, the area of the circle. And I had you guys make 3 graphs. So I'll set them up right here. So we're doing that. Right. So 3 graphs. You guys did what circumference as a function of the radius. So circumference versus radius. Now these might both be in centimeters, centimeters, something like that. Right. Yeah, let's start with that one. So yeah, small circles, medium circles, large circles, all different radial sizes, and then different corresponding circumference. The larger size circle, the larger the circumference. Guys, and all these points, when you plotted them, they all lined up on a what shaped graph? Yeah, linear, straight line, right? Something like this. Or like this. Just a straight line relationship. Okay. Now, maybe your measurements weren't perfect, so a little bit above, a little bit below, but pretty much a straight line direct relationship. Okay. Now, once you have a straight line, it's not too bad to get an equation. If you can find the slope of this line, isn't this basically y equals mx? Y equals mx, except instead of y and x, it's c and r. Right? You can tell me, what is the slope of this line?
-1.
2 times 2 something. Give you a hint. If I start writing out the equation that you guys came up with, instead of y, I'm going to say c for circumference. Instead of x, I'm going to say r for radius. Circumference equals 2 pi r. That's it. Guys, the slope of this was 2 pi. Or you could call it 6.28. Okay. Now, of course, I wouldn't expect you to get this exactly right. So maybe somebody came up with like, oh, it looks like a slope of about 6.19. That would have been good. Or 6.35. That would have been good. But you've been pretty close to 6.28. Okay. You guys were discovering this right here. Circumference equals 2 pi r. All right, let's go to the next one. Instead, graph the area as a function of the radius. So area versus radius. Okay. Again, different size circles, small, medium, large, radius size, okay. And different numbers of tiles. Because when you plotted these points, they made a what shape? Parabola. This was a parabola. So it probably did something kind of like this. It's like, just like that. Definitely a parabola, right? So it looks like area is proportional to radius squared. Now, it's not a full equation. But what that allows you to do is, here, this area versus not the radius, but the radius squared. So if I keep the vertical axis the same, I change radius to radius squared. Towards the end. Square centimeters. Yeah, it's about. Right. And then this graph looks like what shape? Yeah, look back linear again. With the slope here, we got this phone call. Pause this. Alright, we're back. Guys, what did you come up with for the slope of this line? Here. Give you a hint. If it's linear, okay, do basically y equals mx again. Except instead of y, it's a for area. Equals, say, something times, instead of x, it's radius squared. Ah, it is pi. Yeah, the slope right here is pi. Guys, you discovered area is pi r squared. Okay? And maybe you didn't get exactly pi. Maybe you got, instead of 3.14, maybe you got like 2.92. And that would have been plenty close enough. Right, so you guys get on what you were doing with the circles? Right, so you were discovering from scratch. Right, circumference and area. Okay. Oh, here's another way to say this. I forget if I did this with you guys. Guys, if I take a piece of string right here, going back to circumference, and I wrap it around, one string gets me to about there, 2 gets me to about there, got 3, 4, 5, 6, and there's a little left over. Yeah, 6.28 string, like radius kicks around. Right. The other activity I had you guys do was you paired it with a friend. Oh, you guys had a friend back on Friday. Then you drop the ruler, and your friend catches the ruler. Now, this one I'm stealing from physics is the fall height, like the drop height, is proportional to the fall times squared. It has to do with like how gravity pulls faster. Okay, so we got the drop height equals 1/2 times the gravity field times the time of falling squared. Okay, but I want you guys to sort of apply this backwards. So if you know how far the ruler drops, then can you say how much time it was falling forward, therefore your reaction time? You guys got the difference? Okay. First we gotta do some algebra. Guys, can you do algebra in terms of variables? Yeah. Okay, so what's one step? Cross multiply the 2, divide down the g. So 2 times the drop height divided by g. Okay. Now that's t squared. I really want t, so I still have to do what to both sides? Square root. So square root 2 drop height on g. Right. This right here. Now, h represents how far the ruler dropped, and if that was in centimeters, then I told you to use g equals 980 centimeters per second squared, which is Earth gravity. Okay. So basically this right here. So this is what you guys do. Okay. Here, I'll run an example with you guys. So, for example, e.g., if the drop height was, let's call it 24 centimeters. Let's make something up. 24 centimeters. Then the reaction time would have been square root 2, 24 centimeters. I got 980 centimeters per second squared. Okay. Notice this entire expression is underneath a square root. It's underneath the radical. Okay. So I need to express that in my calculator. So I got square root. I got 224 divided by 980. Okay. That's telling me 0.22 something second. So skip that right there. Okay. Now, also a good thing to do is whenever you get an answer in math and science, step back and say, does that look reasonable? Okay, does that look reasonable? About 0.2 seconds reaction time? Yeah, like a fraction of a second.
Yeah.
That looks about right.
Yeah.
All right. If you did this and you got like 2 seconds, and well, that's what math somewhere. All right, so we are ready to move on to 1.5a in the book. So you guys got the book. We're going to 1.5a. This is on page 43. Page 43, we're going to. All right, so piecewise functions. Piecewise functions. So these are pretty fun. It says this is a function using 2 or more expressions, 2 or 3 expressions, but each expression applies to a different part of the domain. So it's like, well, if x is between something and something, then get one graph. If x is like greater than something, maybe it's a completely different looking graph. Right? We'll do some examples. Right. So let's look at their very first example off the bat right here. I'm looking on page 43. You got your book, you can follow with me. It says graph f of, so actually should make a title. Okay. So this is less than 1.5a piecewise functions. And oh yeah. No. This is on page 43. But it's good practice to take notes. Here, I'll probably be walking around the class, see if you guys can draw this. So they give you f of x equals, ooh, and then you get this, it's like a curly bracket, right? And then it splits actually, there are 2 different expressions depending on what part of the domain you're in. Right? So it could be x minus 3. That's if x is less than or equal to 1. It could be 2x. And that's if x is strictly greater than 1. Okay. All right, so what I do is, let's see, set up some axes here. We got x-axis, y-axis. All right, you guys got some axes in your notes? Some? Okay. Okay, if all I said was graph y equals x minus 3, could you do that? Does that look like y equals mx plus b? Yeah. With a intercept of, a y-intercept of -3 and a slope of 1. Yeah, you guys can do that, right? Okay. Now, earlier, some of my students were really struggling with that too. So, guys, if you ever run into trouble making a graph, can you make an x-y table and just plot some points and see what happens? Okay. Now, keep in mind, you're only allowed to go up to 1 for this. So I can go like -1, 0, 1. Okay, but I do have to stop at 1. If I plug in these values for x, -1 here, -1 minus 3 is -4, 0 minus 3 is -3, 1 minus 3 is -2. Okay. I can plot those points if I want to. So down here, -1, -4, 0, -3, 1, -2. Okay. But that's where it stops. So since the graph y equals x minus 3, but you're only allowed to go up to +1 for the domain. So like x can go up to +1, and then it has to stop. All right, that right? Okay. Right. Then anything where x is greater than 1, suddenly there's a completely different function. So y equals 2x. Okay. Now if I gave that to you in isolation, I could say y equals 2x. Guess what would that look like? Would this go through the origin?
Yeah.
With the slope of what? Yeah, 2, like up 2 over 1. Okay. So is it like I'm holding my ruler pretty much right there? Is that like y equals 2x? Right. Now keep in mind though, because you're only allowed to graph part of this, not the entire thing. If you graph too much and you have a pencil, go back and just erase the part that you can't. You can do that. Right. Now I have an ink pen though, so I'm gonna only start graphing where x is. Well, it has to be strictly greater than 1. So here, I'll make a little table up here. Go x, y. Now I'll put in 1, keeping in mind I'm not actually allowed to use 1, but it can go 2, 3. Those are okay. So it's just 2 times x. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Okay. So 1, 2, that's like right. Here, let me get these other ones. 2, 4 is there. 3, 6 is like up here, somewhere about there. Right. Okay, what am I actually going to draw at the point 1, 2? Am I going to make a dot or an open circle? Open circle. Yeah, because the point 1, 2 doesn't actually exist. Okay. Right. Now everything else does, and I know there's the points, but really it's this entire continuity after that. Right? Okay. Okay, you guys get it? Okay. So here's what we got. Okay, so we got y equals x minus 3 if x is less than or equal to 1. That's this one down here. But if x is greater than 1, then it becomes y equals 2x. So all the x values, just double them and then plot that. Okay. I got a closed point down from this bottom half of the graph, and I got an open circle at the end of this top half of the graph. Good?
Yeah.
Okay. And actually, what you just drew in your notes right there, that one, is the same thing at the bottom of the page. There you go. You guys see it's the same thing? Same thing. So that's how it goes together. All right, let's jump straight into these questions. All right, let's do number 1. Number 1 says this is on page 45. Page 45. Number 1 says f of x. So we're making a function equals. Right, the big old curly bar. Ooh, this one has 3. Ooh, 3 expressions. So -1 if x is less than or equal to 0. Could be 2x, but only if, let's see, x is between 0 and 3, including 3, but not 0. Or 6, but only if x is strictly greater than 3. Okay. So let's come up with some axes here. X-axis, y-axis. There you go. Grid lines going. Right, so just one piece at a time. Guys, what is the equation y equals -1? What does that look like? Y equals -1. Right. Okay, I think some of you guys know it, but maybe not everybody. So make a little xy table. XY, see what happens. Now, keep in mind, this is only if x is negative all the way up to 0. So maybe I'll go like x is, okay, let's go backwards. 0, -1, -2. How about -17? I don't know. Right. Okay, so if x is 0, what is y? -1. If x is -1, y is -1. If x is -2, y is -1. If x is -17, y is -1. Okay. Y is always -1, regardless of x, as long as x is less than or equal to 0. Okay. So, okay. So now, what does this look like? Here. Yeah. Okay. Horizontal line at -1 going all the way up to 0. So that could be like this, couldn't it? Right. Now we're including all the way up to the y-axis, so I'll make that solid dot just to emphasize that. Okay. All right. Then, if x is between 0 and 3, right, okay, so really narrow domain, we're just doing between 0 and 3 right here. Y equals 2x. And anything after 3, y is equal to 6. Okay, so go ahead and draw the rest of that graph. I'm gonna walk around the classroom so you can draw the rest of that graph. I got you guys started. Who's going to be able to finish that? You guys got notebooks, you guys got paper, extra paper if you need it. All right, you can draw the rest of that graph. Well, okay, just the expression. So between 0 and so that's the first one, please. That's two. I'm very close. Yeah, it's fair. Yeah. So you know that it's not the next question. That's supposed to be
No, you're right. No, 35.
The five.
That's good, yeah.
All right. All right. So let's get going here. So y equals 2x. Guys, what does y equals 2x look like? Actually, did we just do that a few minutes ago? Does it go to the origin? Basically, where I'm pulling my ruler has a slope of 2, like up 2 over 1. Okay. Now, if all you saw was y equals 2x, you go zip, and then done. Okay. But this one, there's a catch. This only works between 0 and 3. Okay. So, and not including 0. So I'm just going to draw the part from 0 to 3. Actually, at 3, guys, what is 2 times 3? 6. So that's actually, oops, actually, I have my ruler a little bit too steep. So you see, the 0.36. Here, I'll make a little table. X, Y. Let's go 0, 1, 2, 3. So 0.36. Can I just double it? Is that what 2x is? It's just doubling whatever x is. 2 times 2 is 4. 2 times 1 is 2. 2 times 0 is 0. Right. So, or y equals an x plus b if you like. Right. Make something like that. Now, guys, one more thing. Are you allowed to include a 0 in the domain for this middle bit? No, because see, it says x is strictly greater than 0. So how do I show that on my graph? Yeah, put a little open circle right here. Okay, a little open circle right there. I see an open circle at the origin. It's not actually part, right? See if it was, this would no longer be a function because it say, well, what is f of 0? And you'd have a conflict there, right? Now you know f of 0 is only -1. Okay. So we took this all the way up to x is 3 for that domain. Okay. Now anything after 3, y is just equal to 6. What does that look like? Horizontal line. We're back to horizontal line. Yeah, kind of like the first one. It doesn't matter what y is afterward. In fact, y is 5, y is 10, y is a million. X is just, or sorry, I should say, if x is 10, x is 20, x is a million. Y is just 6. Y is just 6. So, flat line, go zip. Right, anything after that. Right. I mean, it picked up at 6. Actually, it picked up at 6. If the last one left off at 6, this one picks up at 6. That's interesting. Because that tells you what? Do I need to also include a hole at the end of this one?
Yes.
Well, I normally would, except that it picks up exactly where the last one left off. You see that? Last one left off at 6. This one picks up at 6. Ah, okay. Right. So that would be the answer right there. Well, whatever. Right, you guys got on number 1? This good? Right. Number 1. I've been doing number 4 here. I think that's worth our time. Let's do number 4. Number 4, real similar looks. But we got an h of x, well, different, equals, okay, curly bracket, it's going to split into 3 if x is strictly less than -1, or we got x plus 1, and that works if x is strictly greater than +1. All right. So up to -1, y, up to where x is -1, okay, y is +3. Guys, what does that look like? Like if x is -10, is y equal to 3? Yeah, if x is -2, is y still 3? Okay. So anything up to -1, not including that -1, just 3. Okay. So I'm going to make a flat line at 3, at y equals 3. Okay, that'll go forever that way. But up to -1, okay, at -1, I have to have a hole at the end. I guess they have a little hole at the end. Okay, because I'm not allowed to include x is -1 because there's no or equals. It's strictly less than. Okay. Right. Then it looks like the domain skips a couple of values. Right? There's nothing between -1 and 1. There's nothing. And then it graph picks up at +1. So where x is +1, where x is 1 or greater. Y equals x plus 1. What does that look like? Is that kind of how I'm holding my ruler right here? As a y-intercept of 1 and a slope of 1. Right. But keep in mind, what's the very first point I'm gonna plot here? Yeah, sort of 1, 2, right? So at 1, why would it be 2? And do I make it a solid dot or make it an open hole? Strictly greater than. Yeah, open hole. So I have an open hole at the point 1, 2. So this is the point 1, comma 2. Just like this is the point. What's that? -1, 3. -1, comma 3. And then after that, I got a rise over run of 1 over 1. Just goes forever that way. If you weren't sure, you could plug in some points. So there's what if I plug in 2 for x? 2 plus 1 is 3. That'd be the point 2, 3, right there. What if I plug in 4 for x? Or, let's do 3. 3. 3 plus 1 is 4. That's point 3, 4. Right there. What if I plug in 4 for x? 4 plus 1 is 5. So where x is 4, y is 5. That's right there. I mean, they were always bound to line up on a straight line anyway. It's linear. All right, guys, good? All right. Everybody's good. Everybody's good. All right, so I do want to do some of these word puzzles, but before we do the word puzzles, I'm actually going to skip ahead in the chapter a little bit. Okay, so we'll run back to the word puzzles. Let's do 13 and 14. 13 and 14. They give you the graph, and they want you to write your own piecewise function based on the graph. There's different ways to communicate things. Right, we just did the backwards of this. So number 14, this one right here. I could say come up with some function. Yeah, maybe I'll call this g of x, just to switch it up. G of x. You call it f of x, probably whatever. Equals. And look, there's definitely 2 parts to this. So let's start with the left side. Guys, what's the equation of just that left side of the graph? Guys, what's the slope on this? -1, right? Like down 1 over 1, down 1 over 1. What's the y-intercept right here? 2. Right. So I think it would be what, -x and plus 2. Wouldn't that be right there? Okay. Then say if, because that doesn't work for the whole graph. That only works if x is what?
Less than or equal to 0.
Exactly. Less than or equal to 0. Yeah. It can be negative. It can also be 0. Okay. Now the rest of that graph. So what's the equation of the right half of the graph?
-x
Huh?
minus 2.
Yeah, guys, does everybody see -x minus 2? It has a slope of -1. It has a y-intercept down at -2, basically. Right. Okay, and let's say if. Right. And that only works if x what?
X is less than 0.
Yeah, x is strictly greater than 0. Yeah, strictly greater than 0. So it's allowed to be anything positive. You're not allowed to include 0, because if you did, because if you included the 0 on both halves of this, then would this even be a function anymore? No, because it would fail the what line test. Yeah, vertical line test. See, this actually passes the vertical line test everywhere. There's only one y value for every x value. Okay. Wait, is that x? There's only one. Did I say it backwards? There's only one. Well, okay, no, whatever. Pass the vertical line test. Right. Okay. Let's do 15. 15. Yeah, I'll call this h of x. I'm just making stuff up. You can call it f of x if you want. So curly brackets. Yeah, that's 2 parts. All right. Ooh. The left side of this graph. What's the equation of just that line? Does it follow the form y equals mx plus b? Yeah. It has a y-intercept of what?
0.
Yeah, 0. It has a slope of 2. Okay. So how do you write that? Is that just 2x? Okay. And if you weren't sure if you got it, could you just plug in some points and try it out? Like if I plug in 0 for x, I get 0 for y. Oh yeah, 0, 0, that works. If I plug in 1 for x, I get 2 for y. Yeah, that works. Okay. I can pick it. Okay. You guys see you did? Okay. All right. Then let's finish the topic. Okay. Because that only works if x is what? Yeah, less than or equal to 1. Right? Less than or equal to 1. Thank you. see like x can go up to 1. You guys see it? Everything after if, we're gonna list the domain with that interval notation. Or sorry, not interval, inequality type notation, right? So this looks like part of stuff over, right? Yeah, x is allowed to be less than 1. It's allowed to be 1, but anything after that doesn't work. Okay. If x is okay, guys, what's this other equation? What's this right here? Y equals what?
-3.
-3. Yeah, just straight -3. Just plain -3. Right. There's no x because it doesn't matter. I mean, x could be a million. Y would still be -3, right? Okay. Now we do need an if condition here. This only comes if x what?
Greater or not equal to 2.
Aha, yeah, greater than or equal to 2. I think that looks about right. Right? So if x is less than or equal to 1, y equals 2x. If x is greater than or equal to 2, y equals -3. Right? Guys, what is, how about this? Since I call this h of x, what is h of 1.5? What is that? Does not exist. Okay. Anything between 1 and 2 doesn't exist on that graph, right? Okay. All right. All right, let's do word cloud. How are we doing on time here? We're we're doing pretty good on time. Good. All right. So guys, here's some word puzzles I got marked out. I got number 12 is I think it's a political poll. All right, got something like that. If I go back, number 11, there's like they're putting a reunion together and it's gonna cost some money, right? And then one I've been doing today also is number 5. We got Mark buying tiles. Right. Now, out of those 3, actually let's do tiles first, and we'll see how much time we have left. Because tiles is the easiest one. The other ones are a little more complicated. Right, so let's start with tiles, and we'll see where we are in terms of time. Number 5, tiles. Mark is purchasing new tile for his bathrooms. The home improvement store charges $48 for a box of tiles. When 3 or fewer boxes are purchased. If he purchases more, look at this, $45 for 48 boxes. $42, this is per box, right? $42 per box for 19 boxes. $38 per box with more than 19 boxes. You see, as it's buying more and more boxes, like the cost per box is going down a little bit at a time. That's it. Right. You guys ever done this? You guys go to the grocery store, and there's like a small bag of candy bars, and it's like, here, I'm just going to make up something, right? It's like $3, and you see a bag that's like several times that size for like $10, right? Something like that. Like, okay, well, the big bag is more expensive, but then you divide out like per ounce or something. You realize, oh wait, actually per ounce, I'm getting a better deal on the big bag. You guys ever seen that? Yeah. Okay. So take that, just replace bags of candy with boxes of tiles. It's the same concept. Right? So let's put together a function for this, and then let's make the graph. So I'll say, could C of x be cost based on number of x boxes? Could that be? X can be boxes, C can be cost. We'll say equals, how many parts are we going to have here? 1, 2, 3, 4. I think it's going to be a 4-part function. All right, parts. Right. Now, guys, suppose he buys 2 boxes of tiles. How much does each box cost? $48. Okay. But how much total money did he spend on 2 boxes? $96. Right? And what I'm trying to prompt you guys towards is, how do you build an equation for, let's say, anywhere for the first 3 boxes? What's the equation to say how much money is going to spend for the first 3 boxes? And you might buy 1 or 2 or 3 boxes. Would it be $48 per box times X number of boxes? Right. That's the equation. Okay? Right, all right? Okay. Again, this has a domain restriction. So this is if X is between what and what? Yeah, 0 to 3. Right? So I'll say 0 less than or equal to X less than or equal to 3. Right? You can get 3 boxes for $48 per box. Right? Okay. So if he buys 2 boxes, you pop in a 2, 48 times 2 would be $96. Right. Then once he buys the 4th box, the cost, let's say the cost of all the boxes collectively drops a little bit. Right? If that was not the case, this would be a little bit more complicated. We'll take it down to $45 per box times X number of boxes. And that's if, what is that, between 4 and 8 boxes? So 4 less than or equal to X less than or equal to 8. Is that true? Right. Then if he buys more boxes, drops down again to $42 per box times X number of boxes. Let's say if from 9 to 19. So 9 less than or equal to X less than or equal to 19. Okay. Everybody following so far? Any questions so far? Okay. And finally, if he buys like 20 boxes, the price per box drops to $38. Right? So take $38 per box times the number of boxes. And that's if, well, how about this? Could I just say X is greater than or equal to 20? Is that okay? Right. Or you could say strictly greater than 19. I mean, you can only buy whole numbers of boxes probably anyway. Sure. I'll say greater than or equal to 20. Right, that's okay. Okay. Now, I wonder what this graph would look like. Make this graph. Well, I think I could just make a quadrant 1 graph. Okay. Aren't these all going to be positive values? Okay. So, open up a quadrant 1 here. Okay. I'll put X number of boxes on the horizontal axis. I'll put cost on the vertical axis. Okay. Guys, we've got to figure out how to scale these axes so we can fit all the data here. Okay. Guys, X should go up to at least what? 20 boxes. Okay. Let's go 5, 10, 15, 20. Okay, and then goes a lot to 0, 5, 10, 15, 20. You guys see how I scaled my axis like evenly and linearly? Right? Like I didn't go like, oh, I'll put 3 here and 8 here and 19 here and 20 here. No. All right, so it's going 5, 10, 15, 20. Okay? Now I can subdivide that. Okay, that's not that's right. You guys get the idea, right? I can get any of those numbers, but everything's evenly scaled. All right, then, what cost should I contain here? Okay, here's a good rule of thumb. Here's what if he buys 20 boxes? If he buys 20 boxes, how much does that cost? $38 per box for 20 boxes. Would that be like $760? Right? Because he's buying lots and lots of boxes. 700. Right. So I'm going to scale this cost up to, let's call it 800. That should probably contain it, right? So let's go 100, 200, 3, 4, 5, 6, 7, 800. Okay, need to extend this axis a little bit. There we go. 100, 200, 300, 400, 500, 600, 700, $800. $800. Okay, so you guys got your axis scaled. All right, so 0 to 3 boxes. See, what would that look like? Well, I know one box would just be plain $48, wouldn't it? That point right there. How about 3 boxes? What's 3 times 48? 144. 1, 2, 3, 144. Right there. That's the point. 3, 144. 3 boxes, $144. Okay. I can connect those with a straight line, just linear. Just like that. Now, once he gets the 4th box, let's say he gets to get all the boxes, each for $45. Right? So the collective price dropped down a little bit, per box. Right? But now he's buying more boxes. So now he's going to pick up 180. So the point 180. That's like we're pretty close to there. Plus the point 180. Okay. And he can take advantage of this price all the way up to 8 boxes. So let's see where 8 lands in. $360. To buy 8 boxes, that would take $360. That's probably right up there. Okay. And then, of course, it's a linear relationship from there to there. So this is the point 8, 1. No, whoops, 360. 360. 8, 360. There it is. 8, 360. Okay. Then the 9th box. See, $42 per box for 9 boxes. $378. So the 9th box is up here at $378. That's 9,378. All the way up to 19 boxes. So if he buys 19 boxes, that would be $798. So 19,798, it's way kind of up here, something like that. That's okay, 19, comma 798. Okay. Then he buys the 20th box. So 20 boxes at $38 per box, because now the per unit price got down a bit. We got 760. So 20. Oops, sorry, that's the wrong point. Right here. 20. Right. 760. Okay. And everything after that is going to be $38 per box. Something kind of like this. All right, and then I guess if you buy like 100,000 boxes, you can just get them for $38 each. Something like that. Okay. So there's your piecewise function. There's your graph. Okay. You guys, a couple of questions about this graph that you guys just drew in your notes. Do you guys see the slopes of these lines? I mean, there's 4 line segments. You guys see 4 lines? Well, 3 line segments, an array, I guess, right? Something like that. Okay. Well, okay. What guys, what's happening to the slopes of these lines? They're getting what and what? Yeah, it is decreasing. So they're getting subtly shallower. Okay. Actually, I can tell you what the slopes are. Guys, or you tell me. Guys, what's the slope of the very first line? 48. Yeah. What's the slope of the very last line?
38.
38. Yeah, because it's dollars per box, isn't it? $38 per box. You guys good? Okay. Here's another question. Guys, what would cost more? Would it cost more to buy 19 boxes, or would it cost more to buy 20 boxes? Who says 19 boxes is cheaper? Or wait, I changed the question to cheaper, didn't I? Okay. Guys, who thinks 19 boxes is cheaper? Who thinks 20 boxes is cheaper? Yeah. Guys, here's the answer right here. 19 boxes cost $798. 20 boxes actually totals less. It's only $760. Yeah. Guys, if you got 19 boxes and you say, I could use more tiles. Yeah. Actually, if you didn't need more tiles, you just got the 20 box anyway. You would still pay less overall. Yeah. Yeah. This actually drops down, doesn't it? You guys see it drops down right here? Okay. Oh, that's interesting too. All right. How are we doing? We got about 5 minutes. Who's got any questions so far? Any questions? Okay. Let's get as far as we can then. Let's look at number 11, reunions. I don't know if I have time to finish it, but we can at least read this and set this up and think about it a little bit. So this one's a little more complicated. I got the cost to reserve a banquet hall is $500. That makes me think of sort of a y-intercept. You guys think $500? Like if nobody shows up, you still got to put down $500 regardless. Okay? The catering cost per guest. Okay, so it's reserving the banquet hall, but then the catering cost per guest is $17.50 for the first 40 guests. I think, okay, yeah, the per guest. Okay. But then the price drops a little bit for each additional guest after 40 guests. Right? Okay. Which kind of makes me think of like the price per box dropping a little bit. Except here's the trouble with that. If there's like 41 guests, you see 41 guests, right? The first 40 you actually have to pay the higher price, and the 41st actually gets the lower price. Okay? That's a little different than this guy trying to buy boxes of tiles, because the boxes of tiles get a discounted price for all the boxes. The guests, that's not going to be the case anymore. Okay? So make a piecewise function. Okay, you guys ready for this one to be a little more complicated? Okay, so we're on number 11 on page 45. So the cost as a function of the number of guests equals. All right, here we go. Okay. So if there's zero guests, what's the cost? 500. So 500 plus. All right, and then there's some cost after that. Okay. Actually, this part isn't too bad. Can you guys write the first equation? It'd be $17.50 per person times the number of guests, which I'll call x. Okay. And this is true if 0 less than or equal to x less than or equal to 40. Right, the first 40 guests. Wouldn't that be true? All right. Okay. Okay. Now this next equation there's maybe different ways to write it specifically. Okay. How about this? Guys, let's take this all the way up to 40 guests. Do 500 plus 17.5 times 40. Okay. That works out to 1,200. So guys, if you had 1,200, if you had 40 guests, the cost would be 1,200. You guys get that? Okay. And anybody after that is going to cost a different price per person. Here, I'll tell you what it is. Works like this. So we're going to put in the $1,200 already. Right? That's already down for the banquet hall plus the first 40 guests. Then say plus. Because anybody after the first 40 guests, you have to pay, well, this lower price. You have this discounted price of $14.75 per guest. Okay. Now here's where it's a little bit weird. But if you think critically, I think you guys can figure this out. Guys, I'm not going to write X here. I'm going to write X what? Exactly! Yes! Yes! X minus 40! And this is that X is greater than or equal to 41. Because, guys, once you get the 41st guess, only the 41st guess gets the discounted price. Sort of. I mean, or collectively, however they paid for it. Right. And that's a graph that would actually show if it's continuous. But we are out of time. But we did pretty good. So you guys have a good night, and we'll do 1-5 tomorrow.